We need to continue talking about end behavior for polynomial functions. We left off with this slide right here. The end behavior in mathematical language uses symbols like the arrow symbol. We read the arrow symbol as approaches. So if I write x and the arrow, I would read that as x approaches. The symbol for infinity looks like an 8 that's sideways. So I would read this whole thing right here. X approaches positive infinity. What that means is the right side of the graph. If we put x and then the arrow and then this, what we would read is x approaches negative infinity, and what that's talking about is the left side of the graph. Now, to tell whether or not a graph is going up, we would say f of x. Remember, f of x replaces y. So this is the same thing as saying y approaches positive infinity, but we never use y. We say always f of x. So f of x approaches positive infinity. Positive infinity. Remember, the y values go up or down, so positive infinity would be up. And f of x approaches negative infinity, that would be going down. When I ask you an end behavior question, the answer is always, always, always going to be either positive infinity or negative infinity. You're never going to answer with a number. Let's talk about example 3. We want to know the end behavior of f of x. That means the y value. What I want to know is, does the y value go up or down as x approaches positive infinity? X approaching positive infinity means on the right side of the graph. So, on the right side of the graph, so that would be over here, is the y value going up or down? Well, since my arrow points down, my y value would approach negative infinity. That means down. So my f of x approaches negative infinity. If we look at the middle graph, remember, x is approaching positive infinity. That means the right side of the graph. So, is my y value going up or down? It's going up, and up is positive infinity. And the last one, as x approaches positive infinity, my f of x approaches positive infinity because my right side is going up. Example 4, what I'm looking for is x approaching negative infinity. X approaching negative infinity is the left side of the graph. So what is my y value doing on the left side of the graph? In this first example, my y value is going down on the left, so my f of x is approaching negative infinity. The middle example, my y is going down on the left, so negative infinity. And the last example, my y is going down on the left, so this one is also f of x approaches negative infinity. What happens if I want to know the end behavior of a graph, but I don't actually give you the graph? All I give you is the equation. If all I give you is a function, an equation, you'll have to think about what the sketch of the graph would look like. This depends on the degree of the polynomial and if the leading coefficient is positive or negative. For example 5, what I'm looking for is a sketch, brief sketch of the function. I'm looking for the turning points and what happens on the ends. And then I want you to tell me the end behavior. So, two things you need to be aware of is the degree of the polynomial. It's 4, which is even. So both ends are either going to go up or down. Second thing we have to look for is this positive or negative. 3 is a positive number, so we know the right side has to go up. An even degree means the left side also has to go up. If the degree is 4, we're going to have 3 turning points. So turn, 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 and we have a brief sketch. So now I want to know the end behavior as x approaches positive infinity. X approaches positive infinity, that's the right side. On the right side, we're going up. Example 6, we have f of x is equal to 2x to the 5th plus x squared. Remember, we need to look at the degree, and we need to look at the leading coefficient. The degree is 5, which is an odd number, so the arms are going to go opposite. One is going to go up and one is going to go down. The 2 is positive. That means the right side has to go up, and if they're opposite, that means the left side has to go down. This is a 5, so it's going to have 4 turning points. So 1, 2, 3, 4 turning points. X approaches positive infinity. That's the right side of the graph. On the right side, my y value is going up to positive infinity. I want you to do example 7 on your own, as well as example 8. Let's take a look at example 9. I have f of x is equal to negative 2x squared. I'm going to look at the degree and the leading coefficient. The degree is 2, which is even, so both ends are going to go in the same direction. The leading coefficient is negative, so that means the right side is going to go down. Since they have to go in the same direction, that means the left side has to go down. Degree is 2. It's going to have 1 turning point. This time I want x approaching negative infinity. That means I want to look at the left side of the graph. And on the left side of the graph, my y value is going down to negative infinity. Example 10. I have f of x is equal to negative 8x cubed plus 6x squared minus 12x minus 9. I have to look at the degree, which is odd, the leading coefficient, which is negative, an odd degree, and a leading coefficient of negative. I'm going to have the right side go down and the left side go up. If the degree is 3, it's going to have 2 turning points. So 1, 2 turning points. X approaches negative infinity. That's the left side of the graph. The left side is going up to positive infinity. Do example 11 on your own. Do example 12 on your own. And let's talk about some vocabulary. Suppose I tell you that k is called a zero of a function. What that means is if k, whatever number that is, so suppose it's 4, if k is a 0, then x minus k is a factor. So if 4 is a 0, then x minus 4 is a factor. We also say that k is a solution, or x equals 4 is a solution. We would also say that k is an intercept. So we would have the intercept 4, 0. So 0, factor, solution, and x-intercept are all related. So if you know one of these numbers, then you know the rest. Example 13, if 7 is a 0, a factor would be x minus 7. Remember, this has to be the opposite sign of whatever this one is. So we would write x minus 7. The factors always have to have an x. The solution is going to be the same, x equals 7. The x-intercept, 7, 0. If negative 2 is a 0, then the factor would be x subtract a negative 2, or we would say x plus 2. Solution would be x equals negative 2, and the x-intercept negative 2, 0. And that concludes section 6.1. Let me know if you have any questions in class tomorrow.